It's a very good thing to see Posidonia live again after 4 years, and Lynn's technical seminars as well again live, as we hope will be our conference in the end of the year. So we have, I think, a very interesting discussion, very interesting presentations today about the future of the technology, which is probably a very blurred scenery, as we talked before with a colleague. And I hope that after this we have some things more clear than we had before in mind. Thank you again very much for coming. I hope you will enjoy the seminar, and I will please ask Mr. Stavros Hatzigrigoris, who will be the keynote speaker and the moderator of the panel discussion following, to take his place and start the event. Again, thank you very much for coming.
Good afternoon to everybody. My name is Stavros Hatzigrigoris, as already mentioned. I have a technical background, working in shipping for the past 40 years. We have, apart from my presentation, which discusses what will happen until 2050, we have the General Secretary of the Ministry, the Aegean and Island Policy, Mr. Koutoulakis, who has been delayed and will give a short speech whenever he arrives. We have Mr. Stamatios Fradelos of ABS. He will talk about regulatory development and expectation in the MEPC 78. We have KK Lee, who is the Senior Vice President, High Power Systems AVL. Who knows what AVL is? So you have to say a few words about AVL, KK, I think, before you start your presentation. Okay? We have Dr. Nikolaos Themelis, who will talk in general about ship energy efficiency design aspects, not concentrate, I believe, on fuels or on other things, talking about ship design. We have Mr. Panos Zachariadis, who will talk about the new IMO and NTUA regulations and how these will affect shipping operations. And we have Mr. Carlo Aicini, who is the head of Marine Environmental Panel of Ajax, a newly established panel. And I also propose that you say a few words about this panel before you start your main presentation. So we can start. Έλα να τα βάλεις γιατί το... So the title of my presentation is Ship Emissions 2023, which is tomorrow, 2030, 2050 and beyond. I don't know how many of you know about the Doomsday Clock. Who knows about the Doomsday Clock? 1, 2, a few more than they know AVL. It's a panel of scientists who every year estimate what are the new threats for the planet and say if we have a long time to adjust. In 1953, the main issue was the atomic bombs, hydrogen bombs, and at that time we had 2 minutes to midnight. Next was the Cold War, 1991, with 17 minutes to midnight. Next was 2019 with the nuclear treaty, that was 2 minutes, and 2022 what they have said is that the Ukraine war risk and the climate change give us 100 seconds to midnight. You understand what is the size of the seconds in this for them. Long time ago, what was said was that the available energy is the main object at stake in the struggle for existence and the evolution of the world. That was somewhere between 1844 and 1906, if we change the first word in this saying, with sustainable, I believe this is what we are faced with today. We are at the turning point. There have been a number of conferences discussing climate. We had the Paris Convention, we had the Glasgow meeting, and we had the Davos meeting very recently. This is what NASA foresees for the climate change. You can see how much the temperature of the planet has risen over the past 800,000 years. Who intends to live for that period? Nobody. Okay, good. And it's not a nice graph. And we have an estimation that was done a long time ago by Gabrieli and von Karman. And what they have said, and what we believe as people of the shipping industry, is that shipping is the most efficient and less polluting form of emissions. We have the SOx emission. This is already passed, but it's still recently we see a revival of the intention to feed scrubbers. The main reasons for this is the price differential between low sulfur and high sulfur fuel. We have the NOx emissions, who are creating quite a few technical issues for the manufacturers, the designers and the manufacturers of the engines. And we have greenhouse gas emissions, which in my opinion is the most serious issue and the one that has to be tackled first. And there are a number of goals set up by IMO. Unfortunately, the IMO, number one, is a slow organization. Number two, their work was affected a lot by the COVID, and because they could not have face-to-face meetings and they had to work in groups. But these are the measures that were announced a few long ago, maybe, and that are still on the agenda of IMO. We have the energy design index for energy efficiency design index for the new ships. I calculated, just to have some fun, the EDI of Titanic, the EDI of the Liberty ships. We go down from 55 to 24 with the Liberty ships. Then we have a very interesting ship, that was the Europe in 2002. That was a ULCC delivered 20 years ago that could meet the EEDI requirements of today. And the reason for this was that the ship was large, 450,000 deadweight. And you can see some calculations for ships that are being delivered more recently. This is the same table form. The effect of EEDI as calculated by Norway, it's not a very recent calculation, but their estimation was 15% to 2015, 25 to 2020, and 35% to 25. EEXI, I think it's the discussion of the day, because it will take into effect soon. And what you can see on the table is what is required for different ships, different design of ships. And it is the first, this is the CII, and we have to say that it is the first time that the ships are ranked depending on their actual emissions. It's not a design index, it's an operational index. And this is an estimation from ABS on how the EEXI will affect the existing fleet. 87% of the bulk carriers have to do something, 80% of gas carriers, and 78%, sorry, I'm reading the CII. For the EEXI, 87, 88, 85, and 95, a little less for the CII and a little less for the different categories of ships. what are the prospects? One of the problems that we have is that apart from the CII, the whole industry has to improve. To 2050, it's 30-50% or 40-70% per ship, as IMO has said. Prospects for growth population, although yesterday the report was published that all these have to be revisited, but according to the latest projection by the United Nations, the population of the planet will increase by 22.52% to 2050. I was in a seminar maybe 2 years ago with a few oil majors, and they were all smiling. When I asked them why do you smile, they replied, because we estimate that the energy consumption will go up and not go down. And so this is the future growth. You can see it also by continent. Europe will go down, Africa will go up a lot, South America is projected also to go up. And the Australians, they cannot keep their population at 22 million for a whole continent, which will also go up. These are the projections against the United Nations for the seaborne trade. Some sectors, especially the tanker sector, are forecasted to diminish. Bulk carriers, they say the seaborne trade will increase. Containers will increase a lot. Gas carriers will increase a lot. The total growth is about 25%. And this is not helping the industry if the targets are set by industry and not by ship. GDP growth, who can talk about the GDP today? I don't know, but these are the projected numbers. Alternative fuels, I'll focus a bit on alternative fuels, and I will not talk about regulatory issues because they will be covered by the other speakers. What we have to evaluate today is 12 different solutions for ship propulsion. Keep in your mind that for the past, if I'm not mistaken, around 70 years since when coal was stopped to be used as the main fuel for ships, we have been with basically one fuel, or say two fuel, MGO, distillates and heavy fuel. Looking at if they are long-term solution, this is the graph that shows what is the carbon effect from those fuels. There are disputes as far as the use of LNG is concerned, what is low pressure, what is high pressure. And there are disputes about ammonia, because ammonia, especially at low load, may need quite a lot of pilot fuel. People are saying 30 to 40%, but this has to be tested and proved before the engines are introduced. This is a matrix that I developed to show where we are today. This is an evaluation of production, storage and logistics, installation, progress made with the design of propulsion systems, and safety issues, and of course zero carbon issues. What is red? It's a long way to go. What is orange has to be further studied. What is green is something that we already have. And there are several other interpretations for the same matrix. I've seen one from ABS and it's a bit different. I've seen one from Lloyd's and it's also a bit different, but this is my personal opinion. Energy density, the properties of the new fuels, there are big differences between them. As an example, hydrogen will need 4 times more space to store, if you can store it at a temperature of -256. And these are also the basic properties of alternative fuel. The presentation will be available. I tried to make this presentation as a reference presentation. It will be available in the site of a link, and if you want to leave your email, we can send it to you, so there is no need to take pictures. We can take pictures of the panel. Liquefied natural gas, Some people like it, some people hate it. I'm not going to mention names. But it seems that it is the closest solution to improving emissions today. I believe that LNG is a transient fuel. It's becoming different if we talk about blue LNG, green LNG, or what can be developed in the not so far future. LPG, I don't think LPG will help in my view. It's only about 15% of reduction in greenhouse emissions. But LPG may be a solution for LPG carriers. And there are ships on order today, a few of them have been delivered that are using LPG successfully. LPG carriers. Methanol, a question mark if it will be available worldwide. More easy to burn than other fuels. You don't need many modifications on your engine. Handling is a small issue. There are orders for methanol vessels by Maersk, by Hapag-Lloyd, and still there are discussions about ordering more ships with methanol. Ammonia, there is one engine, test engine that has been installed in Denmark by MAN that will start testing, from what I understand, from the MAN people here in August. They say that they will have an engine ready by 2024. I think it's a bit short, this period, to test the engine, to produce the drawings, and to test it in service. It seems that if we talk about two-stroke, this is the closest solution for a new fuel, and this is the timeline of MAN as published 10 days ago. Biofuels, they have the advantage that you can mix them with heavy fuel, so if you want to reduce your emissions by 30%, you can add 30% biofuel, and you are okay. My personal view is that the targets should not be 30% or 50%. We should have a target, the maximum possible reduction of emissions, and not stay with predetermined numbers. Biofuels have been tested on board several vessels. They are not available worldwide at this point. And there is I don't know if I can call it the ethical issue if production of biofuels will reduce production of food, and food is something that we need. Hydrogen, very difficult to handle. There have been no two-stroke engines designed until now with hydrogen. I understand that there are small four-stroke engines utilizing hydrogen, and I understand recently Wärtsilä have tested hydrogen on medium power four-stroke engines, and the results were quite encouraging. Hydrogen is a solution. Producing, storing and handling hydrogen is difficult, but there are solutions to produce the hydrogen on board. As you understand, all these are new technologies, and they have to be well tested before applying them on board. I mean, nobody wants to see a repeat of what happens with the scrubbers and the ballast water treatment systems. What we have to all the emissions will be monitored. It's a bit different than scrubbers, a bit different than ballast water treatment systems. Synthetic fuels, I don't know if you know it, but the German army was using synthetic fuels during the last years of the Second World War, and it was a successful test, but they will be expensive and intense labor to produce them, intensive labor to produce them. Solar, it may be a solution, a backup solution. I don't believe that we will see soon solar-powered ships. Fuel cells have been tested in military applications, navy applications. It's something that it's coming, but the cost is at this moment is 7 to 8 times more than a conventional propulsion system. Batteries, we discussed where I work the possibility of using batteries that will last for 2 days for a 10 megawatt power on a reefer container, high reefer capacity container ship. The cost of the batteries were 104 million, the cost of the ship was 94 million. So, still early. Wind power, I think it is coming. We all talk about Flettner rotors. If you look the picture at the left, it's not a very modern solution. The first Flettner was produced was tested in 1924. What rotor manufacturers are saying now is you can reduce the propulsion efficiency by about 1% per rotor at a cost of 700 to 800,000 US, of course depending on the size of the rotor and the size of the ship. Nuclear power, a few years ago, was promoted by one of the classification societies. Then somebody told them to stop and they stopped. Now we have the same discussion again. There are new technology nuclear reactors. They call them molten salt reactors. They are using as fuel enriched with uranium or thorium molten salt at a temperature of 450. They have two advantages. The enrichment is too low, so the fuel, nuclear fuel, cannot be used for the production of weapons. This is number one. Number two is that if there is a leak, the temperature of the fuel will immediately go down and the reaction will stop. So they are considered safe, but of course we have not seen a prototype reactor. This is a solution encouraged by our big friend Mr. Gates. I believe we will see it. The Americans are supporting it a lot, but still there is no prototype reactor in operation. They say one prototype reactor will be ready in 2027. Carbon capture is something that we will have to discuss. My personal view is that the solution to many of our problems will be carbon capture. There are about 15 companies today trying to produce efficient and cost-effective carbon capture system. The theory is that you can using chemicals which can be ammonium hydroxide or amines. You can you can either liquefy the CO2 and deliver it to shore facilities in liquid form, or you can reduce CO2 to solids. The solids are calcium carbonate, and they say, of course it has not been regulated, that calcium carbonate can be thrown directly into the sea without causing any environmental problems. The other method of producing CO2 for ships that are fueled with LNG is to use the cold energy of LNG. We have to heat the LNG before sending it to the engine to liquefy the CO2. The temperature of LNG is minus 160. Temperature required to liquefy CO2 at environmental, is about 52, 53. So you can, technically you can do this. What is the footprint? What is the cost? It's still to be seen. Small engines have been tested. Carbon capture has been tested on small engine and it has been proven successful. There are three ships at this moment that are provided with experimental carbon capture system. One is in North Europe, one is in Japan, and one is in Korea. It can give us a solution. These are the three solutions that I already mentioned. This is the path if we go for LNG. There are many non-governmental organizations and individuals that do not like the idea of LNG. a report was published recently for this cruise vessel, the Aida, that I saw yesterday. It's also calling Greece at this moment. They were saying that the use of MGO was better in terms of emission than using four-stroke propulsion engines with a high methane slip. And these are my questions to the shipping coalition that produced this report and sent it to IMO. What will be the cost? This is a study that was published in 2020. This is a simple, an Ultramax bulk carrier. It's a concept design, as you understand. Nobody has ordered such a ship. It has a sail forward. It has solar panels on the hatch covers. It has batteries. It has LNG propulsion. And that's about it. The cost of this vessel, estimated cost of this vessel, I understand that prices in shipyards are market driven, but an estimation is that this ship will cost, was to cost 2 years ago, 2 times more than the cost of an Ultramax at that time. Cost of Ultramax has gone up 30% this moment. Maybe more. And this is where the traditional cost is. Conclusions, my conclusions, I think we are all willing to discuss them. We must have a holistic approach for emissions. It's not only SOx or NOx or particulate matter or CO2. We have to look at them in a holistic approach. We need green technologies to be developed, and this is where we need also the support of governments. The government should support green technology, research and development for green technologies. Reliability is important for marine equipment. We cannot have ships that break down every second day, although this will increase the manpower request for all engineers here. New technology, as I already mentioned, will increase the cost of the vessels, and I believe there will be problems with maybe not the high-end Greek companies, but the traditional, more or less traditional Greek company with, say, 2 to 15 ships. Investment will be more difficult for them. Understanding the technology will be more difficult for them. What I forgot to mention before, because a lot of people will say nuclear, who is going to run nuclear ships? Part of the service that the nuclear, the people that will produce nuclear reactor is that they will have 2 nuclear reactor engineers on board for the whole life of the ship. The crew will not deal with the nuclear reactor. We need better education. We need the universities to look forward, to improve their curriculum, to improve their whatever they teach. We need better marine academies for the people that will sail the ships. And I'm not in full support of what we call autonomous vessels. I think for the first decade or so, autonomous vessels will be shore controlled. They will not be autonomous. Somebody will have to see what they do. Transparency is important. We have to talk to each other to reach commonly approved solutions. At this moment, I think splitting our research capacity to 10, 12 different fuels is not helping, but we have to do it. Time to break the tradition, of course. I think everybody has realized this now. Shipping cycles will get longer, this is my view. And the factors that will affect shipping a lot, as I mentioned already, is the cost of the ships, the cost of the fuel, and how well we can cope with new technology and digitalization. As management companies, we will have to upgrade what we do. We need, as I said before, also enhance the reliability and maintainability, and supporting LNG a bit. I think LNG is a solution that can be applied at this moment, and and stay there for the next, for a transition period for the next 10-15 years. Well-to-wake theories, I believe, will be discussed. My personal view is that shipping should not be held responsible for what is happening until the fuel is on board, but it seems that there are new trends developing. That's about it. Thank you very much.
Fradelos, I'm working for ABS. I'm head of the Regulatory Affairs Department. I joined ABS a few months ago. We are responsible for following up the IMO, the developments, the regulatory developments in IMO, and passing this information internally to update our rules, our process instructions, certificates, etc. Of course, informing our clients and trying to let them know about what is happening and how we can support them. But also my department is dealing with the flag administrations, the agreements and the authorizations to do our statutory work. And we are also coordinating the activities in Ajax. So we are, I'm also a member of the Ajax Council meeting, and we are also getting the General Policy Group where we participate as members. So a few words on regulatory developments. Actually, this week we have the IMO MEPC 78 meeting that's currently going on, and we will give you some latest discussions. So first thing which is very important in the regulatory agenda is the revision of the IMO GHG's initial strategy. The discussion started from the previous MEPC meetings and will continue. Possibly, I'm sure we are all familiar with this trajectory line that IMO introduced within the initial strategy for decarbonization within the century, and we have two targets in 2030 and 2050. Now, however, there is a discussion and there is an increasing support to go to a stricter trajectory line to have zero emission by the year 2050. And a new target you can see there in the year 2040, and there is big support by IMO influencers like United States, Canada, Europe with all EU members, Australia, New Zealand, and it seems that this during this meeting it has been discussed the second and the third day, and now they said let's move forward and we need concrete proposals about the text to revise the strategy, and this will be discussed at the next intersessional working groups and the MEPC to be finalized next summer in MEPC 80. And of course this is a very important development which will affect the effort that we will have to put all together for the decarbonization. The draft G5 guidelines have been approved yesterday, so these guidelines now introduce some correction factors trying to, let's say, make the whole CII implementation framework more fair. Okay, so there are some voyage exclusions, considerations for tankers, correction factors against on ship-to-ship, ice class, and correction factors for chemical tankers. These have been approved. We have also amendments on the EXI guidelines that have been approved. You are going to see a revised set, we call 2022 set for the EXI guidelines. Now the changes there are actually introducing the in-service measurements for vessels that they would like to go for sea trials and produce a new speed power curve. This is also a very important discussion within IMO. This is related about the life cycle GHG intensity guidelines, and which aim to incentivize the uptake of zero and low carbon fuels. It has been mentioned earlier by Mr. Hatzigrigoris about the well-to-tank and tank-to-propeller emissions. As you know, currently we are, through the DCS, we report our tank-to-propeller emissions. We have the carbon factors and we're reporting this part of the emissions. We will continue, and for international shipping, only the tank-to-propeller emission will be accounted within the IMO inventory. However, we are going to have information about the well-to-tank part, so ship owners can make informed decision about the fuel they are going to change. But for the tank-to-propeller part, as you can see there, now we will have the introduction of the methane slip, also mentioned by Mr. Hatzigrigoris, and as you can see there are already some proposed factors to calculate the methane slip and the equivalent methane emissions and also the nitrous oxide. And what it is also very important to note is the introduction of the source factor that you can see there, multiplied by the carbon factor. And as you can see here, for the fossil fuels, the source factor is 1. However, you can see for biomass, for those operators looking to burn biofuels, or for fuels that are going to be produced by carbon capture, you can see that under some specific provisions, the source factor could be 0. So for the fuel mix, the part that relates to the biofuels, for example, we have a B30 or B20, 20% biofuel. For this part, the CO2 emission can be 0 if this part of the fuel, this biofuel, is properly certified. This is coming at the next level, next stages in IMO is the discussion of the midterm measures. This has been already started. Maybe you are already familiar with the International Maritime Research and Development Board. This is proposed by the Ship Owners Associations, putting $2 per a levy on fuel, $2 per ton of fuel, and the funds they are going to collect about 5 billion within the 10 years lifetime of the program to invest on research and development. Previously also mentioned about the need to have research and development and to see what will be the next solutions and the next fuels. Similar proposal by China, supporting by Argentina, the International Maritime Sustainability Funding and Reward Mechanism. This is based on the CII framework, where ships that will be found in categories D and D will have to pay, and this money will be invested on ships that will be in categories A and B, and research and development, and supporting of developing countries. We have also this proposal from Japan, the zero emission vessels incentive scheme that you can see here. Those ships that will continue to operate with fossil fuels, they will have to pay a levy, and then these funds will support those, let's say, first movers, ship owners that will invest in zero emission ships. And actually, Japan, into their analysis, they say that less than $100 per ton of CO2 equivalent will be sufficient enough to support and incentivize the uptake of these zero emission fuels. We have the emission cap and trade system. This is supported by Norway. It's actually a cap on the emission specific to each ship, and a ship will have to pay for these emissions units the allowance to emit in the atmosphere. This is similar to the EU ETS that we are going to discuss later on, that is coming from Europe, and the GFS, the fuel standard. This is the proposal by European Commission and all EU members. Actually, they say we need to set a limit on the GHG intensity of the fuels, actually the carbon content of the fuels, and we have to reduce this carbon content over the years. So, moving to the next, this has been discussed on Monday, and it has been approved, so it will go to the next MEPC meeting for adoption. Is the Mediterranean Sea designated as SOx ECA from 1st January 2025, so ships will need to use 0.1 sulfur content while operating in this area, or the SOx scrubbers. This is under discussion. We have, there is a recognition that ships operating in ports with challenging water quality, they have problems, filters clogging, difficulties to manage the ballast water management system. So this is under discussion in a review group these days. Actually, their report back to MEPC committee in the plenary today. We are expecting their report, and there is a proposal that ships facing such problems to be able to bypass the system while importing when they are outside in the ocean to carry out sequential exchange and treatment, and then to have clean ballast water. And this is my last slide. This is related not to IMO but from regional requirements coming from Europe. We have the EU Fit for 55 package. Maybe you are familiar with this because Europe has recently increased the level of ambition for reduction of GHG emissions from 40% to 55% by the year 2030 compared with the 1990. That's why they came up with a legislative package, and it is called Fit for 55. We have two committees currently in the European Parliament, the TRAN committee, which is leading the discussion on the fuel EU maritime regulation, and we have the ENVI committee that is leading the discussion on the EU ETS. Yesterday we had the vote in the Parliament, however we had an unexpected, unpleasant development where the Parliament was not able to vote and to agree on the proposal by ENVI committee, so it will take more time now to see whether when the EU Parliament will be able to reach an agreement on the ETS. Few words on the ETS. It's actually based on a carbon pricing. You can see here the price of carbon, how it's fluctuating over the years. Now it's about 85 euros per ton of CO2, so ships will have to pay based on the CO2 emissions. And the EU Fuel Maritime Regulation is a totally different concept. Actually, it is based on the ETS is on tank to propeller emissions, while the EU Fuel Maritime Regulation is on well to propeller emissions, so it considers all the life cycle of the fuel. They are going to set a GHG intensity limit based on the data that they have collected through the EU MRV for the year 2020. They are going to set the limit. We are expected to be about 90.3 CO2 emissions per megajoule, and they are going to reduce this limit over the years. Every 5 years they are going to reduce the limit. And you can see here in the graph an estimation about how these fuels, the different fuels, are performed based on the limits that they are going to reduce over the years. And you can see here what is previously mentioned by Mr. Hatzigrigoris about the 4-stroke auto engines. They do not perform so good. Actually, they are worse than the liquid fuel. However, you can see there the LPG and the LNG on 2 strokes, based on the default values, is actually a compliant fuel up to 2040, based on the default values we have so far available. And this completes my presentation. Thank you very much.
My name is KK Lee. I claim I'm half Greek and Korean. Simple reason. I like to be together with the growth of the Greek maritime, but beside the appearance, I'm still very dull in Greek speaking. So that's why I'm half Korean, half Greek. So I'm, first the correction, my introduction, I became a professor first before I finished PhD. I'm still remained as a professor, so I didn't finish my PhD. That's a small correction. I work for little bit Institute of Nuclear Physics, and then I started my career for the actually nuclear power plant construction company, Korea Heavy Industry, and then I moved to Aegean and served there for 20 years, and then I became let's say EVP for the DEO shipbuilding and engineering, and then soon after I became a professor for the National University of Maritime Korea. And now I'm also associate professor of the Griffith University as a part of the EU Erasmus program. At the same time now I'm working for AVL. I can tell to my marketing colleagues they were successful because in this room only 2 persons knows this name, and still I would say to them there is a room to improve because there are still 2 people knows it. We are the brain power. We shouldn't be supposed to know what we are doing because we are working as a brain for our customers. It's a private-owned institute. We have 11,000 plus people, and out of 11,000 plus, 7,000 are researchers, scientists and engineers and technicians, and then 1,200 are software engineers and 600 are for the fuel cell, let's say, developers. So it is world's biggest brain power, but we are working only on the request. Whatever government or institution or industry, we don't mind, we are just developing for their need. And today I could see there are 2 people still knows it, so we have to improve ourselves. Okay, what I'm doing is, at the moment, I'm responsible for the design and development. 3 people. Even more. Okay. So just to get to know you a little more, we have developed a high-speed engine. Normally, high-speed engine is serving for the automobile industry and power plant. Whole industry of maritime to use for the internal combustion engine. The engine consumption for the whole maritime industry is less than 3% of engine business. So you can imagine how big the engine business is. So it's a huge industry. And we developed 1,150 high-speed engines. And very successful, nobody knows it. And then for the big engine, including all these big size maritime engines, we have developed 156 engines. And that is a little bit of representation of what we are doing. I wouldn't say yes, including the highest speed car in the world. Okay. Other speakers will speak about these emission regulations. This will impact to the ICE or already impacting. This is one of the issues I like to share with you. And also, before I forget, I would say thank you very much for the organizers. My old friend Stavros and Demetrius, also the chairman. Thank you very much for inviting me, and it's a great honor. I was almost forgotten to say that. Thank you very much. And then I would first mention already what is the role and importance of maritime, let's say, transportation. We are carrying more than, in reality, over 87%. Okay, there are differences, but you could easily say more than 80% of whole trade is done by maritime industry, and we are emitting only 3%. It's really unfair that we are really blamed by many institutions. You can compare, you see, we are 2 times better than rail traction, we are 6 times better than truck, we are 40 times better than air freight, but we are still, let's say, claimed. The why, I will explain a little later. And to solve our common keys, I know right now you have a burning problem, because your burning problem is to comply CII, EEXI. This is your burning problem. I know you have to solve this, you are totally focused on, but very soon you will have another burning problem. This is coming, and this is what we have to aware, because we have all organizations, including myself, IMO, all classification societies, whole industry, we are misusing or we are mixed using decarbonization and greenhouse gas. This is 2 different things. But when you focus on decarbonization, certain method and certain fuel is perfect. But when you are talking about greenhouse gas, it is not always like that. It looks like hydrogen is an ideal solution, like a silver bullet to solve everything. And we, in our institution, we have tested hydrogen, ammonia, and mixture of hydrogen and the ammonia and hydrogen and the natural gas. You can see here all these different fuels. We have most of the fuels we have tested or plan to test. So we have some knowledge, and according to our knowledge, these two must be different. And what is really impacting to our climate change? Is it really carbon dioxide? That is a question mark. Actually, some measures on the ship, if you focus too much on decarbonization, this will be a measure you should yourself, your own fit in the future when government or IMO start to regulate greenhouse gas, because internally they are already discussing about this difference. So this is very, very important, and I wouldn't go too much in detail. All this fuel we have tested together with our partners, and there we have recognized, simplified the figure here. You need extremely high energy for the ignition of the ammonia. Instead, you have a very low, let's say, energy for the hydrogen. It is very contradicting. That's why we try to optimize. That means mixture. We take a good, here and there. That way we try to optimize. And another very important thing is greenhouse gas. If it is the case, then what is global warming potential? We have a very big dispute. Either we take a global warming potential 100 or global warming potential 20. This will give a totally different, because if you take a global warming potential 100, then ammonia is 287, and let's say methane slip is 28. So ammonia is 10 times more than natural gas. But if you take 100 to the global warming potential 20, then it is equal. So it is a huge difference that we have to be very, very careful in this moment. And another one is already mentioned many times, well to wake. This is another one I will not mention because this will be repeated. And then you have summarize. We can summarize that there are three clusters how to solve this. First is internal measures. Why not just measure it by the technology? And this is one cluster, but we have recognized by this, let's say, cluster of the technology cannot solve the problem. That's why we need help from the fuel. That's why we are all discussing about different fuels. But that is not enough, I would say. So we need another way of after treatment. This could be a carbon capture and utilization as well. So we all have to. Now, to solve or to comply our common issue, we have to increase our communication and our cooperation. This is extremely important. And then this is under the condition that internal combustion engine will remain as main drive for the power for the ship. Because as I told you, it's still 3% of whole market. So there are another big windmill which drives to continue this as a prime mover in our society. That's why it's very hard to believe this will be disappearing by another day. We made a small calculation because we have also a department. We are developing also the battery and the storage system. And we have made two scenarios. One scenario, we are sitting on the best technology, and this will develop for next 10 years, best of best. And then we made a simulation for the 23,000 plus 21,400 TEU container vessel from Rotterdam, Singapore. We have calculated the average demand of the power is 30 gigawatt hour. And this calculation, if we use this electrification, you need 60% of total mass of the ship to be battery. So what can you do? Okay, to increase your volume for the cargo, you increase, of course, you have to increase your battery. Yeah? And then another calculation, we have cooperated, that is a Fraunhofer Institute in Germany and also Technical University of Graz LSC Center, which we also part of them. And then they calculated from the present technology, and that resulted 100% of the mass. So basically, ship can carry his own battery. That's it. That is two calculations, and these two very simply prove the low physics actually, because internal combustion engine carries only 2% of the energy, because 98% is coming from the air. You see, the internal combustion engine is just converting energy from the air and then combining carbon from the fuel and then sending back to the air. So it is a matter of how to clean them. It is not the issue where we should kill them or not. I think this is a public deception. We should really work to communicate, to understand, let's say, more correctly. So please, this is one key message. Internal combustion engine carries only 2%. The battery system, as I told you, 100% with the present launch. And we have summarized what could be the technology to comply all those three clusters. Beside the technology, that means the fuel side and after treatment system. And we would say we are ready. All this cascading knowledge is developed. So we are ready to comply to any kind of a demand of the fuel and also the after treatment system. And carbon capture is one of the really, really interesting, promising technologies which we can combine it all together. So I will not go to detail here. And then just a quick look about the fuel, how this fuel in maritime has been developed or evolved. It's a very strange enough when the first steam engine developed in 1812, and then the solid fuel, the coal, served exactly 100 years until the Zealandia launched with the first diesel engine 1912 from Burmese main shipyard. And then I was myself on a major contracting partner 2012 and 6th of December. There's a first real commercialized ocean-going big-sized ship with LNG fueled. So it is another 100 years. I don't know why each time 100 years, but that is. And then we have to discuss about the new fuel because so far the condition to be a maritime fuel should be bulk. That means very economical, and then ship should be able to sail anywhere in the world, so it should be globally available. So availability is very important. Of course, the safety is no need to mention it, but now the environmental aspect is one of the most important among all. So that's why now we are entering new era, let's say new net zero carbon fuel. This is what I summarize. And I have just quick checked about the status. At the moment, the status today, more than 50% of new order intake is dual fuel. And also today, more than 80% of the new engine orders are 100% for the four-stroke, and then mostly remaining also even to two-stroke. We have more and more LNG fueled ships. So it is 50 and 80 altogether. We could say previous slide I have shown we are entering to the new era of the fuel, which is gaseous fuel era. This is the background, and also there are smart customers who are using the best out of everything, which means they are taking a best part, which means if we can gain, as previous speaker said, LNG could be a let's say transitional fuel. Why not use LNG fuel to ship now and then to be ready for the ammonia for the future? Then it's a smart investment, right? But the problem is LNG, you need a nickel-based material, but this nickel-based material, the ammonia is poison. This is the problem. So if smart way, if you can find the material, this material can stand for the LNG and also ammonia. This is the best. You know, stupid Korean have developed this material long time ago, and now they have launched in the market, and this material can stand minus 198 degrees. And hydrogen is minus 253, so they are still developing further to accommodate all three different fuels into the one material. And now they can do that. But at the moment, the material production capacity is very, very limited. And I know about XX amount of the ships are already ordered for this. So they are the really, let's say, smart investors, I would say. And then on the right side, you can see what is the ship ordered. You can see still it's a very, very few percentage if you are considering the, let's say, overview. That's why I would like to mention for you, maybe you could think about this kind of flexibility, to be more ready. And this is from DNB, sharp increase of the LNG, because everybody believes this is a kind of transitional fuel and potential if there is material available. That is right. And I like to summarize this, let's say, technologies and also fuel event in terms of internal combustion engine is concerned. And now I view only up to the 10 years. I cannot see more. So maximum 10 years. Okay, within 5 years is obviously CII, EXI you have to focus on. But there, I would expect, this is a result of interviews, because I was myself curious from last November, and I started to interview all major engine OEMs and major shipyards and made the interview, and this is a summary. And we can say two-stroke will remain for obvious reason, and of course this is for ocean-going ships, and the four-stroke serves more for this, let's say, the special area of the ship, and the alternative propulsion system will serve more on, let's say, inland waterways, coastals, or small, or this kind of category of the ships. And with the power to X, we are now building a kind of demonstrator how much real fuel from air can be produced. And according to our calculation, 1 megawatt you use, and we can produce 500,000 liters of fuel a year. And we are now actually, because people are not believing if you say that generating fuel from the air, so we are building a 200 kilowatt size of electrolyzer as a demonstrator. And this fuel we can produce about 13,000 liters. So if that is combined with the carbon capture, and this will be a very good future, and this will be a very good measure to serve for the greenhouse gas 2050 goal. And likewise, fuel I have mentioned already, but there is a really bottleneck technology, that is material, and also a fuel gas supply system and fuel injection system, and also turbocharging system, also ECU. You can, if you have a mixture of the fuel or complete different fuel, how this fuel can respond to the maneuverability by the demand of the captain in the harbor. This is another aspect. So there is a very good knowledge and technology have to be followed. And also, people are talking about the methane slip, but I am very positive. Both if global warming potential 20 or 100 is applied, and but I see these three methods I have measured, an internal measure and the CH oxidation catalyst, and also the methane slip solution software, etc. I am very positive to solve these issues. And then I have updated, but this was already, let's say, reported by the keynote speaker. I will not repeat. And here is another, let's say, presentation made by the DNB. What is the, let's say, projection in the future? For the sake of time, I will go to another slide. What could be the sketch for the future? What would be the pathway, especially for the ship owners society like Greece? I think now it is, sorry to say, we are entering into the complexity society. That's why we need the cooperation and more communication. And previously, you could just order a ship by simple specification, but not anymore. You see here, when we are entering to the greenhouse gas, let's say, composition is an element we have to comply, then the complexity will remain even more. And one thing many technical providers are forgetting is crew training. You see, this is very, very important. How is a crew behaving LNG carrier? How many years and how many money we have spent to crew to facilitating how smart they can handle, how safely they handle. You see, you have a vested technology, but if crew connecting the LNG pipe mistakenly, this escaped or leaked LNG is maybe 100 times more than methane slip from engine. It's very, very important. If it is methanol, ammonia, what will happen? So crew training, and then plus, all these technologies very much depending on those technologies of fuel injection system and also ECUs, lots of new components. As we all know, ships have to be able to sail all around the world. How can you secure the components? How do you source? So where is your supply chain? And this supplier for the engine manufacturer or this specific manufacturer, if they say, please wait 6 months, will you wait the ship for 6 months? So this is extremely important. So that's why I would really emphasize this Hellenic Institute, this association, make a discussion together and in a group, and then why not exercise your power to press on, not press, I would say, more request for the cooperation for those, let's say, suppliers association. Let's talk. What is your plan? What is our demand? How we can compromise? How we can secure this supply chain more safely? So this is another very important point I would like to mention. Of course, this is much better than I do, so I will not mention it. And for this simple reason, I believe the internal combustion engine will prevail. This is a very, very, so it's simple, clean fuel in, clean gas out. Very simple. And also another thing is the knowledge about engine, we know what's in there and we know how to handle it. And we have a lot of people who knows that. So I will end my presentation in this way. Many people, when there is a storm or windy, then they say, oh, we have to think about why we have a sail. It's not the time we have to think about the sail itself. It is time to think about how to adjust our sail. This is already more than 2,000 years ago in this land, as Nikolaos have said already. So let's see our old associate, very, very old associate, already told us the future of internal combustion engine. Thank you very much for your listening.
Engineering, National Technical University of Athens, and I'm going to present design aspects related with ship energy efficiency. So I will try to be short, and the presentation has 3 parts. The first one I will summarize basic design measures focusing at high level. In the second part, I will provide some indicative research activities at NTUA. And in the third part, I will give some case studies related with performance assessment of design measures in real operation. So, okay, we have some mature measures. I will call them short-term measures that aims at improving fuel efficiency. And if we focus on hull propulsion, we have 2 major categories. We have hull form optimizations that aims at reducing hull resistance and increase propulsion efficiency. And we have both at the design and as a retrofit. And the key point here is to start thinking about optimizing at off-design conditions related to draft speed and considering also weather effect. We have seen that due to slow steaming, some designs are not performing very good. So we have some need for optimizations, and bulk optimization are a popular choice nowadays. And of course, at the design level, we have to think about optimizing hull form and less on the industrial design optimization. So this table presents some indicative fuel savings found from the literature and other studies. The second category is concerns propulsion improving devices. It's also mature technology. We have a lot of applications. In some cases, they try to correct some not optimal designs. So have some smell of ducts, for example. And such devices are not perfect for every design. So for slender or faster vessels, you can have press wheel friction stators. For full form vessels and for lower speeds, we have press wheel stators with accelerating ducts, like Levis duct. And for post-wheel devices, we have aim at improving slow steering conditions. We have some rudder buds and box cap fins. So all these devices to implement it, we need detailed engineering analysis, and we need model test or CFD results. And it's also a question how they can apply in real weather conditions and in real operation conditions. And this is one of the case studies that I will present later. Now let's pass to less mature technologies, and I will present two basic or two popular choices among the less mature. The first one is the air cavity lubrication, where here the intent is to reduce skin friction resistance, and this can be happened with two mechanisms. The first one is through the generation of bubbles, and the second with the development of air layer. Now, we have several vendors that provide such systems. They claim that for potential fuel savings up to 10%, but there are some possible issues to be concerned, and this is the impact of the propeller efficiency, so if the bubbles can affect the propeller. We have also the effect of ship motions, so this system cannot work in extreme weather or in severe weather conditions. And also more commonly is the energy needed by the system, so a large amount of energy needed for operating this system. So some ideas new concept that comes for a passive lubrication system. And here I have an example from a company where they utilize Venturi injectors to create their water mix. So this needs much more less power. But of course it's in a low TRL level, and they are trying to test the system in real conditions. The second category, that also Mr. Hatzigrigoris mentioned, is the wind assistant propulsion systems. So we have several winds and technologies here, and several range of power savings for each one of them. Of course, they depend on the vessel size and hull form and the wind conditions encountered. Some are more mature and they have starting to develop in the real ships. Others are in the design level. We have some new ideas about semi-rigid systems and semi-rigid sails that can locate it in a container. They can deploy it located back in the container. We have also some attention lately for the towing kites, draw some attention. Okay, now let's go to more research activities in research level technologies. Firstly, we will see some results from a project run in NTUA. It relates with hull form optimization. The project is called TRAM, and its aim is to design a fully electric passenger catamaran ferry. And in order to save space and need less power for the batteries, we have to optimize the hull form and the beam of demi-hull to reduce the resistance. And for this reason, we have used a CFD tool and an optimization procedure using genetic algorithms to find, for example, the optimum hull form or the optimum beam of demi-hull. So this is new designs. And we have also some another ideas where we have here a starting wing that is deployed in front of the bow, and this is results are from a SIPTEC project, and the wing has a positive effect of reducing ship motions and acting as a trim beach stabilizer. This leads also to a reduction of the hull resistance, and we have some numerical and experimental investigation. We have seen here the testing facilities at the NTUA where the system has been tested, and you can find some gains about reduction of resistance about 20 to 35%. We have also some numerical results. We have for CFD motion, for CFD results regarding the ship motion and without the system, and with the system you can see the reduction of the waves produced. Now, for the last part of the presentation, I think it's interesting to start testing the effect and the performance of these systems in real conditions. And because we have several cases that such systems and measures are introduced, and then we monitor their performance, and we start asking ourselves, okay, where are the savings that have been promised? And we present some case studies that are based on diploma thesis that I supervised, and I think this highlights also the high level of our students here at the school. So the first case corresponds to a container ship, and they proceed with balance bow modification and a propeller replacement. And this is because they operate far away from the propeller, from the design point and the optimized design point, which was about 24 speed, and the operational range was decreasing to 15 and 17 knots due to slow steaming. So in order to evaluate how these design measures, if they were successful, we have operational data, and we have high frequency operational data before and after the retrofit. And we utilize mathematical models based on machine learning techniques and feed-forward neural network to estimate the main engine fuel oil consumption. The problem here is that the retrofit occurs simultaneously with hard cleaning during the dry dock, and this needs that some special treatment for the time is needed. And we have two-step approach here. We concentrate on the period after the retrofit, and here we can see data, and the blue dots are the real measurements for the main engine fuel oil consumption. The red ones are based on a model that is trained with the data before the retrofit. So this is the predicted. And in concept, the difference between these predictions are the effect of the design measure. It's the effect of the retrofit. And we can see that have a difference of about 25%, which is quite significant. The second approach was to develop two models. One was trained with data before the retrofit, and the second model was trained with the data after the retrofit. And we carry out two case studies. In the first one, we generate some testing conditions, assuming some distribution for the key parameters of the problem. So we have combined 1,000 of combinations of testing scenarios, and we can see here we can develop the distribution of the fuel oil consumption. We can see that we have a mean reduction about 50%. And if we concentrate on a single operation scenario, it's about the mean conditions about the draft trim and 68 curve, and use the models to calculate the fuel oil consumption in terms of speed, of ship speed, we can see that there's a significant reduction for the lower speed range, and this confirms the effect of retrofit. And for the higher speed range, this reduction is diminished. So indeed, there's a significant reduction of the retrofit that it was succeeded at retrofit. The second case study corresponds to an air lubrication system, and we have gas carrier, and we have real-time measurements of testing the system operated and when it's closed. And here we have a preliminary analysis. This is based on a thesis that is in progress. So we have measurements with the system on and off. We have carried out some normalization, some filtering for keeping for moderate weather conditions. Sea current is also below 1 knot. We have some correction for wind resistance. And here we can see the power speed curves the measurements derived from the system on and off. And if we do the analysis, we have this gross power saving by the system for a range of speeds, and starts above 10% and gets lower for the higher speeds. But important here is that we need to consider also the power needed by the system, and we have these values also for this range of speed. And if we remove this power, the net power savings is ideally at about 4.5% for a range of speed of 16 to 17. So this is an important amount, and if we try to find systems that can have a lower operation power, this amount of net power saving will be increased. The last case study regards an MEVIS duct installation, and we again have a lot of operational data before and after the installation. Here we have the installation of a MEVIS duct for a Suezmax crude oil tanker. It was more difficult to see savings for this system, so we use also a second vessel, sister vessel with similar operational profile and maintenance. That has not the MEVIS duct. And we use KPIs and the multiple year regression models to estimate the fuel oil consumption for several conditions. And we can see that there are some gains for the laden condition, lower speed in the long term after dry dock. So this is the presentation. Try to highlight some design measures that are affecting real operation. Of course, the savings cannot compare with the fuel solutions. These are more short-term measures. They are measures for existing ships, are retrofits that can improve their energy efficiency. And of course, there's a real question if we can combine such system, what is the benefit? This is not an easy answer because the problem is not linear. You cannot just add the percentage of savings. And again, it's really interesting to examine which is the real benefits of implementing such system for the real operation. So this is it. Thank you.
Okay, I'm Panos Zakariadis, Technical Director of Atlantic Bulgarians for many years. I go to IMO as part of the Greek delegation for many years. I'm part of BIMCO Environmental Committee and also a recent group of BIMCO that were making those clauses for the charter parties, the ETS clause, EXI clause. We're done with those and now we're finishing up the CII clause. I just want to give you some news because I don't even know if Mr. Lee knows about hydrogen. That has nothing to do with my presentation, but I read a couple of days in Bloomberg that hydrogen in the future may be said to be a greenhouse gas. I don't know if you know that, because we know hydrogen is not a greenhouse gas. When you burn hydrogen, it doesn't emit any greenhouse. If it escapes to the atmosphere, it doesn't warm the atmosphere. But the more the scientists look the more they find things. And what they found is it affects the life of methane in the atmosphere. So we said before that the greenhouse gas potential of methane, if you look at the first 20 years, is 100 times worse than CO2. Is 30 times, 28 times worse than CO2 for 100 years. But if you look only at the next 20 years, it's 100 times worse than CO2. And the reason for that is that methane interacts with some other elements in the atmosphere, and its effect, greenhouse effect, reduces. So hydrogen, when it's emitted in the atmosphere, interacts first with those other elements, and it prevents the methane from interacting with those same elements. So therefore, in the future, that methane 100-year potential may increase and hydrogen may be a potential greenhouse gas. So the result is there's no silver bullet yet. So we don't know where we're going. Anyways, today's presentation, I'm not going to speak about how silly the regulations of IMO are for CO2. I have said that many times before, but they're here, and except for the fact that we have to live with them, they also have some good side effects. Okay, it's not all bad. And the good side effects is we are going to need collaboration from now on. That we said before, collaboration between owners and charterers. So starting with the EU ETS, Mr. Fradelos mentioned that yesterday it didn't pass. There is actually two directorates in the European Union. There is the DG Move and there is the DG Klima, the General Directorate of Transportation, the General Directorate of Climate Change. And those two, actually, they fight between themselves, okay, a little bit. And the DG Klima wanted ETS to be applied to shipping. DG Move, because they are transportation, they know better ships. They know that ETS is not the best suitable measure for ships. So they wanted a levy. So finally, in order to have everybody happy, we got both an ETS and a levy, and we got the levy in the fuel EU. So the EU ETS, I'm not going to spend too much time on it. All the emissions, if you're coming or going from the European Union, 50% of the emissions of the trip will have to be surrendered by allowances which you buy in the European carbon exchange. And we hear a lot of things about the Greek ship owners pressing the European Union to include in the ETS the responsibility of charter, because when you charter the ship, the fuel is purchased by the charter, so he's the one who's doing the emissions, and therefore the charter should be responsible for the allowances and not the owner. So there were quite a few lines included in the revised draft, but all those changes, I call them cosmetic, because in the final analysis, the party that is required to surrender the allowances to the European Union is the ship manager. So once it's the ship manager, then he has to get the allowances from the charterer. So it's not really that the charter is regulated, it's cosmetic, what I call. And of course, there is no free allowances for shipping, but now that 2023 is actually 2025, and we'll see what happens with the vote in the European Parliament. But the first they raised, there's going to be a phase-in period where the first year 45% of the required allowances are going to be submitted, and then the next year 75%, and the third year 100% of the allowances. So that will make trips to the EU a lot more costly. And a small example here of one of the ships we operated, Atlantic Balkarias, for a 14-day trip. That trip will cost extra $67,000 if you assume that the carbon price is at $85 a ton, which right now is a little less, but has been up nearly $100 a ton. Within trips within the European Union, 100% of the emissions will have to be accounted for, and that will cost $9,500 extra. And of course, big trips from Asia to Europe, they're going to be more expensive. And there's going to be other side effects. And I know Professor Stavros has written a paper on this about the side effects of ETS. Commodity flows will change because obviously now people are going to prefer shorter trips rather than longer trips to carry the same. So the economics will be changing. And now grains from the Black Sea before the war or after the war are going to be preferred instead of transferring grains to the European Union from faraway places. And then the other side effect that it's almost certain that's going to happen is that countries close to the EU, like Turkey or Morocco, they can have hubs where if you have a very long trip from Asia, you can discharge your cargo over there, and then this can go further on to the European Union, perhaps with smaller ships. And of course the European Union knows about this, which is called carbon leakage, but the problem is it's very, very difficult to control it, because who can keep track what cargo is loaded now in Morocco in the smaller ships for transport to the European Union? And of course, we all know that keeping track of an ETS system is a huge administrative burden, especially for the small shipping companies. You have to imagine, you have to keep track of your emissions, you have to go to the carbon exchange and buy the allowances, you have to submit the allowances. All this is a huge burden. And finally, this actually is in the BIMCO clause, the ETS clause. The owners want to be sure, if you charter your ship for 1 year, you want to be sure that the charter will give you the allowances. So you better request the allowances on a regular basis from the charter, and not at the end of the charter, because at the end of the charter, if the charter doesn't pay up, you're going to have a serious problem with your ship. And of course, there is a big question, because the ETS regulation is not ship specific. It doesn't target the ship, it targets the manager of the ship. And the manager usually manages many, many ships. So the question is, if one of the managed ships of a big manager that manages ships for many owners doesn't produce the allowances to the manager so he can give them to the European Union, it is most probable that all the ships in the managed fleet will be blacklisted by the European Union. And that's, I think, a mistake in the regulation. And I think instead of trying to lobby the European Union to have the charter being responsible, it would be better to try to change the regulation from manager specific to ship specific. Because we have all the data for the ships, of course. We have IMO numbers, we have 30 CU MRV, the European Union knows all that data is submitted. So it would be more appropriate, I think, that the ship should be targeted. And then, if you think about it, even if the European Union wanted to have the charter responsible, they cannot do it. There is no database of charterer, and a charterer can be a charterer for one trip only. Buys the cargo, finds the ship, and then the next day disappears. So this lobbying to have the charter responsible, I think, is misguided. Let me move to the CII, but what I show there is the actual formula for the EXI. This is not the CII. And I show the formula just to say that despite how the formula looks, EXI is very simple. EXI is just a limit on the power of the ship. And now, talking about how those regulations are going to change the relationship between the owner and the charterer, if you have a ship on charter and you apply EXI, then your maximum speed changes. So you can describe in the charter party, okay, because of this new regulation, my ship now, before it had a maximum speed of 14 knots, now my maximum speed is 13.5 knots. The charterer has to agree to it because it's a regulation. Finished. That description of the ship is valid for the remaining of the charter and for the remaining of the life of the ship, actually. But this is not the same with CII, and that's where the problems come. Practically, CII is fuel consumption by distance, and that has to stay within the sea range every year. And every year we're going to have a 2% drop of that sea line. So every year it will be more and more difficult to be within the sea range or above. And just a side comment here to say, I mentioned about silica regulations before, we are rating the ships like they are refrigerators, okay, the refrigerator system that I say, but this is not a valid efficiency index for the ship. This is because, for example, you can have a very efficient ship, it goes to a port, the port is busy, it has to stay, let's say, for 15 days, your CII index is going to be, adversely affected drastically. And then at the end of the year, that ship is going to be a D ship. Is that a real representation of the ship? No, of course. That's why I don't like this kind of operational indicators. So, what does that mean for the actual operation of the ship? That the owner and the charterer, they have to be in close touch. The owner has to pass to the charterer all the data so the charterer can understand the CII rating of the ship. And a problem you can imagine is that in the beginning of the year, in the beginning of the charter, a charterer can order the ship to its maximum speed, which is controlled perhaps by EXI. But then for the next voyage or for the next 3 months, the owner will have to say to the charterer, sorry, you cannot order that ship to that previous speed. Now you have to go lower, because if you don't go lower, I'm not going to be in compliance with CII. And the charterer, of course, this is practically a regulation addressed to the charterer, which is a first in shipping industry. The charterer doesn't know about regulations that are applicable to him. So they need to, this thinking that the owner is against the charter and the charter parties have clauses to protect one and clauses to protect the other will change from now on, and necessarily there will have to be a collaboration between the two parties in order to comply with the CII. So this is how I see it changing from now on, and I think it's going to be a major change to have actually the charter and the owner collaborating to achieve a regulation, because they will have no other choice. So that's it. Thank you very much.
The classification societies and the choice that the Ajax has made in recent times concerning these new regulations. As we saw, the IMO strategy for 2030 and 2040 will cause the carbon intensity of shipping and the total emission to be reduced, and the targets are getting stricter and stricter. But our view is that the initial requirements will mostly be complied by efficiency improvement, like the one that we just described with CII and EXI. But the further steps for the following year require really changes in the technologies. We have heard about development in the technologies that have been used, and this includes especially new fuels. So most probably new fuels will come to the market. This would be ammonia, hydrogen, biofuels, synthetic fuels, but also batteries, nuclear power, methanol. We heard all about them. Most of them will be impacted by if IMO will introduce a life cycle assessment of the environmental impact, because there's especially the sustainability will be challenged by life cycle assessment, because most of them for their production are relying on availability of spare energy, but actually this spare energy is not available in the world. We are just struggling to produce enough renewable engine for other industries. That is not available this spare energy for producing fuel for shipping. So that will be a really game changer. However, we expect that technologies would be developed, helping to go along this route. However, these fuels we know will bring to the market the new hazards, especially because most of, for example, hydrogen is highly flammable and explosive. Ammonia is toxic. All of them have problems with the volume and energy density, and so the view of Ajax is that there will be an impact on the safety of the ships when using these new fuels and technologies. So the idea is that class is to guide industry in the during the development of these technologies to ensure that the ship safety is not impacted going along environmental requirements from IMO. Examples of these can be seen, for example, in the IGF code for the use of liquefied natural gas. But these new fuels will bring different risk. For example, if we pick, for example, of hydrogen, hydrogen has a property that is very permeable. That means that hydrogen will permanently leak through any kind of tank. So it's not a matter of preventing leakages, but it's just a matter of how to deal with leakages, which will inevitably occur. We expect probably to have multiple barriers for hydrogen, but hydrogen in liquefied form is stored at a so low temperature that there is no suitable material to be placed in the interbarrier space. Because, for example, if you place air in the interbarrier space of a hydrogen container, air will solidify. And so one suitable solution is helium, but helium has an enormous cost, and so it's not that suitable. It's not available at this stage in the quantities required for the industry. Just to give an example of the barriers and the safety aspect that will have to be addressed by the industry. Other aspects, for example, for ammonia, we know that ammonia is toxic not only to humans but also to the environment. So during operation of the ship, there will be inevitably some leakages of ammonia, and some regulations are to be placed to regulate the release of ammonia, both to the air and to the sea. So we need the regulation in terms of total quantity of ammonia released, but maybe also in terms of concentration of the ammonia, not to impact the environment. I mean the nearby environment of the ship, because if a ship has an overpressure, it will release ammonia, but may release ammonia within a town, for example. That is good. So we have to discuss about the concentration of ammonia, because ammonia is toxic to lethal level at much lower concentration than it's flammable. So we have to discuss probably about protective location of tanks, because in case of collision or groundings, the impact on the ship itself, but also on other the surrounding of the ship may have to be impacted. So probably the protective location of tanks on board ships have to be reconsidered. We cannot rely on the statistics that are available today for all tankers, and so probably new studies are to be carried out concerning ammonia leakages for large volumes of ammonia, and concerning its diffusivity and toxicity for the humans. Also, other points are the position of vent masts, because this system will leak ammonia, and these leakages are to be collected and discharged to a safe place on board the ship. And so a safe place on board the ship is to be found for this discharge. Other problems could be the concentration of these gases in the crankers of engines to avoid the explosion from the engines. We have to identify which are the allowable levels of these gases on board the ship, to define the warning levels for detectors, and to require safety action to be activated. Summing up, there are so many issues that are still to be defined for the use of this fuel. So The point is that we have identified that classes are to collaborate with the industry, to identify practically viable solutions, but we have to go along the same way. So while these technologies are developed, it is the role of the classes to develop also the regulations to help the industry go along the right route and prevent the industries to face against new regulations. The idea of Ajax was to create a new safe decarbonization panel to deal with these aspects, and this panel has the clear indication that it has to collaborate with the industry to develop this new regulation, and obviously this panel has to collaborate with IMO. The idea is that IMO should just fix goals, general goals, and the industry together with classes could develop detailed requirements. We are at the very beginning of this process. I'm proud to announce that I have been nominated as chair of this Ajax Safe Decarbonization Panel. So I see that it's a really challenging task, and I ask all the partners from the industry to help in this process. Thank you so much.
I will please closing the seminar. I will ask Mr. General Secretary of the Ministry of Shipping to have a short placement and close the panel. And just to remind you that the presentations and the video will be in the site of a link and in YouTube, so you can have all of this whenever it's convenient. Please.
Thank you very much. Good morning to everybody. I know that the time is pressing, so I also punished myself because I came 30 minutes later. So I punished myself because I had to listen to all these great presentations, so it's difficult for me to take you to another level or aspect of our other point of view, but which is connected with technology and this dialogue. First of all, I would like to thank the President and the Board of Members of the Hellenic Institute of Marine Technology, who is becoming slowly but steadily an institutional stakeholder of the Ministry. And I'm very glad for being here today, because I came and see with my eyes what is the discussion and what is the level of your actions. And I think for the next period we have to organize, as we have already discussed about that, a more specific roadmap for introducing those difficult dialogues, but also in other rooms that need to be discussed. And I will speak about that in my short, not presentation, but more or less address to this great seminar with these great speakers. Honestly, I'm impressed. Think global, act local. This is why we're coming now, and we have to discuss about that, because technology factor is one of the great factors that you are dealing with. We are dealing with the local problems that we have to connect, the evolution of the technology and all the discussion about the environmental aspects, but at the same time we have to provide services to our islands, to our waterborne transportation, and especially in the islands. So this is part of our strategy also that creates the path for introducing projects, proof of concept, but at the end of the day we have to introduce specific solutions for the things that we have to face the next years, for the next 10 years. And take into consideration that Greece is like a small test, not a small one, but a real test bed for all these applications of the technology. But in the passenger shipping and the fleet that is referring to the passenger shipping, which is maybe a completely different way of thinking, because I heard about ammonia. As you know, in the passenger shipping it's not something that can happen. We are very happy as a Ministry of Maritime Affairs and Insular Policy. I will be very fast in 1 minute, thank you. It's important to create a mechanism for the application, because we need to see the results in the next 10 years in the small routes and in the regional routes. The passenger shipping and the passenger fleet, they need to change. We have 40 years old vessels that need to adapt to the new environment, not only in the laws, but in the real need. But this needs a planning from end to end. Not only the vessels, but also the port services and infrastructure. We work with the European Commission closely, and for the first time as a ministry, we are trying to create a mechanism for funding, for giving incentives to the owners, the ship owners for the passenger shipping, so they can adapt and they can renew the fleet. This is the idea, this is the plan. We're discussing about that with the Hellenic Institute. I'm closing my remarks because I'm realizing that it's almost finished. But it's important to have a stakeholders engagement in such seminars, but also in a discussion that is coming in the next days and next months, because we have already discussed and agreed with the European Commission for this specific need for funding of the renewal of the fleet, so technology along with the territorial aspect of our policy formulation. So this is a great seminar. The next steps is to combine technology with other aspects and factors that need to be addressed also in Greece. Thank you very much.
Thanks to exceptional speakers. Thank you, Mr. Secretary. Thank you, Mr. Hatzigrigoris.